Now you can ask your doubts.
Sir,
Huh.
so since we are actually it is a breadth first search, no sir. We have to move in a like a breadth first search direction, no sir. Actually, but
No,
here
you
we are
have to
moving
follow
with
the
a cost,
heuristic
no sir.
distance.
Okay.
You have to follow the information or the guidelines given to you. It is a hint. H of n is a hint they have given. You have to use that hint and you have to solve this problem.
Okay, sir. Yes, sir.
Okay. Because the prior information is given. The difference between informed search and uninformed search is uninformed search is you don't know what is where you have to follow and which is the goal state and which is the source, which is the destination, you don't know. Here you know the prior knowledge of the searches. You know what is the distance between the each node to the destination. So the prior information is given. You have to use that prior information. For that only we are using this procedure.
Yes, sir.
Okay. If you follow like that, then there is no need for going for breadth first search. You can directly go for breadth first search and you can solve this problem. If I go breadth first search, what I do? S, A, B, C, D, E, F, H, I, G will come. The total cost is more and the solution is not optimal and you have to visit all the nodes. Here you are visiting only S, B, F, G. If I visit this one alone, it's enough to reach my goal. So if I take breadth first search, what I'll do? I'll go with S, A, B, C, D, E, F, H, I, G. I visit all the nodes and my optimality will be more time complexity is more, space complexity is more. Since I am having a hint here, based upon this hint, I have solved this problem within 4 steps. It's correct.
Yes, sir. Yes,
You
sir.
have any other doubts in this one? This is very, very important problem. Please, students, if you have any doubt, you ask me. There's no hesitation in this one. What others may think if they ask this question, don't worry about that one. You need to clearly understand the steps. If you write this problem, you write this table, you write this solution, you'll get full marks. But in topmost universities and all, they'll give the problem. For that problem, you have to find the solution. Okay, they will not ask the explanation about best first search. But as far as our university syllabus is concerned, they ask you to briefly explain in detail about breadth first search with an example. Is there any doubts? And we proceed to the next search.
Yes, sir.
Okay. So if they ask, what you have to do is you have to write this. What is best first search? Step 1. This algorithm you have to write. Place the starting node in the open list. If the open is empty, stop, return failure. Remove the node from the open list, which has the lowest value, h of n. Then place it in the closed list. Expand the node n. Generate the successor of node n. Step 5, check each successor of node n. Find whether any node is the goal node or not. If any successor node is goal node, then return to success and terminate the search. Else proceed to step 6. For each successor node, algorithm checks for evaluation function. Check the node is been either open or closed. If it is not has been in the both lists, then add to the open list. Return to the step 2. This is algorithm. You can write on your own also this algorithm. No need to exactly write this as such in the book. Okay, if you understand this concept of best first search, you can write the algorithm on your own. Okay, you have any other doubt in this one? Can we move to the next one? A star
Yes,
search.
sir. Yes, sir.
A star search is also known as admissible search. Then we can see what is the difference between best first search, A star search. A star search. A star search is most commonly known form of best first search. It uses a heuristic function h of n. The cost of each node from n to start node g. It has the combined features of uniform cost search, greedy best first search. It can solve the problem efficiently. A star search problem. Algorithm finds the shortest path through search space using heuristic function. So here the heuristic function is g of n plus h of n. The A star algorithm is f of n is equal to g of n plus h of n. Estimated cost for the cheapest solution, optimal solution f of n is equal to cost to reach from the node state to the from start state, cost to reach from the node state to the goal state. Algorithm, disadvantages, advantage, disadvantages, example of this problem. Okay. Now, what is the advantage? A star problem search is best algorithm than other search algorithms. A star search algorithm is optimal and complete. Algorithm can solve very complex problems. Disadvantages is it does not always produce shortest path as it mostly based on heuristic and approximation. A-star search algorithm has some complexity issues. The main drawback of A-star is memory requirement as it keeps all generated nodes in the memory, so it is not practical for various large-scale problems. For this only we are using the next algorithm which we are going to see is constraint satisfaction problem. CSP problem is very, very important in artificial intelligence. Now we're going to see what is A star and how to perform A star search with an example. What is A star algorithm? Now I have the graph. I have the nodes marked and the cost of each node is given here and the heuristic distance is also given here. As best first search, I am having the cost from S to the goal node is 14. SB to the goal node is 12. F to the goal node is 11. G as cost 5. C as cost 11. E as cost 4. D as cost 6. This is given. This one is given. Now I want to follow A star algorithm to solve this problem. We are going to see how to solve this one. We have f of n is equal to g of n plus h of n. Can we go for this one?
Yes, sir.
Okay. Now, if I go for S as a source node, I have the cost as 14. So I have to take this path cost as well as this cost. So what I'm doing is 0 plus 14. So my answer is 14. It's clear?
Yes, sir.
Now I am going to, similarly, I have to follow any one of the path. I have to take B or I have to take C. Here it is B and C. So I am going to see which one is optimal. Now I want to calculate f of so I am having here, you can write here as yes. So I am starting my exploration from yes. So I am writing here yes. Next I want to follow B or C. If I take B, f of B, if I take the node B,
12.
S to B, what it is there? S to B, 4.
4
What is
plus
the
12.
distance, heuristic distance?
12.
12. So it is 16.
16.
Now if I take C, actually it is not f of B, it is what it is.
Yes, sir.
It is not f of B, f of S tends to B.
Extension.
I have
Yes.
to write like this. Yes, because I'm starting my exploration like this. If I go for f of S tends to C, S to C, what it is?
11.
3.
3, sir. 3, 3 and
What is
11.
this value of C? 11.
11.
So this one is 14.
14.
So which one is optimal
C
here?
only, sir.
Optimal is 14. 14. Okay. If I compare these two, which one is optimal? 14. It has lowest cost. So my path starts from S to C. So I am leaving this one. If C, if I take the path C, what are the two paths here for C?
D and E
Either I can go E, D.
or D.
So my exploration starts like this. S tends to
C
C
tends to D.
tends to E. This one path. Another path is F tends to S, tends to C, tends to what is that? D. Correct?
Yes, sir.
Or I can write instead of this also, can I write like this also? You can follow any procedure. Instead of S tends to C, I can put as SC tends to E, SC tends to D. So what is the cast here?
It is
S to
10,
C,
sir. Sir,
10.
it is C to E, sir.
That was C to E.
Yes, sir.
S, now S is closed here.
It
Okay.
is 4, sir.
C to E, 10.
4.
How it's 4?
Yes, sir. In the box, no, H of N.
S to C, you have marked here.
Hmm.
C to E. What is this one? S to C, 3E
13.
plus C to E, 10. What will come here?
It will be 4, sir. 4, sir.
C to
E, sir. E.
E, E is 4. So what is the total?
16.
16. Here, 3
Plus
plus
7.
7.
Again on D, it is 6. 16. 60.
So you have same
Yes, sir.
E, D. So again I have to check with D and E. First I check with E. E I have only one root here. If I have C to E, E to G is only one root. If I take this path D, I have to go to E, then D. F of S, F, S, C, E.
So it is D.
What's the value here? 3 plus
3 plus 10 plus 5.
here
For E,
3,
it is 4. G, it is 5,
5.
sir.
So total is 25, 28, 31. Huh? What's the value here?
23, sir.
15, 18, 20, 23. Here
3 plus 10 plus 7.
7 plus
10. So 3 plus 10 plus 7.
how 10 will come?
C
S
is
to
there.
C 3, C to D 7,
S to C,
3
it is.
plus
Yes, yes. Sorry.
7 plus E 2.
2.
Here E is 4.
4.
So what is 10, 12,
16. 16, sir.
16? So the I'm going from S, C, D, E. This one is minimum.
So we are going to one more state now, sir, in the above.
We have to find the optimal fast. That one is a goal. S,
So
C,
if we be going from S, C, D, E, and G, then we'll be getting the other cost now, sir.
S, C, D,
E and G.
D and G.
S,
Now you can see
C,
this one.
D, G.
S tends to C, so what will be 3 plus
3 plus 7 plus 2 plus 5. 2 plus 5.
yeah,
And for G, it is 5.
so 10,
21.
20. So the optimal path is S, C, D, S, C, D, E, G. This is the optimal path. So it takes how much? 21
21.
through A star algorithm. Have you understood this algorithm? If you have any doubt, you can ask me.
So, but with less number of nodes, if you are starting from E, then it is reaching early nodes, sir.
No, the early
Apart
is
from the
suppose
cost.
you if you
Apart
think
from
this
the
is
cost.
a say a kilometer, okay, I can reach the destination by 21 kilometers. Here it takes 23 kilometers. 2 kilometers you're saving here, no?
Yes, sir.
If I go by here also, I am saving 2 kilometers instead of going by this way.
So, but thinking logically without any cost, but we can directly move from
No, if you are
E and
traveling from Chennai to Coimbatore,
yes, sir.
though you see that the cities are located like this. Suppose if I take this as a shortest route here, if I come here and go, this distance is reduced by 2 kilometers. Then I'll go by this way or go by this way.
Yes, sir.
I'll go only by this way.
Mm, yes, sir.
Correct.
Yes, yes, sir.
If I go by this way, so this is my route. S C B E by A star. A star search is known as admissible search. For each step, you have to calculate f of n is equal to g of n plus h of n. G of n is actual cost from start node to the node n. H of n is estimated cost. You have any other doubts here? Is there any other doubt? If you have doubt, please ask me. See, if I compare this with this also, this one only is minimum. So this is an optimal path solution. So if you write in the exam, you have to write this example like this. You have to write this table. You have to calculate the f of n is equal to g of n plus h of n. You have to mark the state. You have to calculate the source from the destination. And you have to mark this source to destination as a path. And you have to say that S, C, D, E, G. S, C, D, E, G is an optimal path or a solution using a star search. So what is the difference between, we have seen what is greedy blissful search, what is a star search. The important thing is what is the difference between greedy blissful search and a star search. Greedy blissful search follows a combination of both breadth first search and depth first search. A-star search follows uniform cost search and greedy best first search. This is the main difference. In breadth first search, it takes only the distance of the goal node, distance to the goal node, that is estimated cost only it takes for problem solving. Here it takes the both actual cost and estimated cost to reach the goal. This is the difference number 2. The optimality of the algorithm is easier in A-star search than best first search. This is the difference number 3. If you want to write in more depth, you can write the time complexity, space complexity of both the algorithm, and you can solve this problem. So the space complexity will come ordinality of d power d, branching factor power depth. Time complexity is order of d of power d or vertices plus edges. Is it clear?